Okay, so this is problem number, wait a second, this is problem number 25, gate 2025 physics. So what are we given? So it is said that which of the following options is or are correct for photons. Okay, so we are being asked that its rest mass is 0 but its energy is non-zero. Fine, it carries non-zero linear momentum, it carries 0 spin angular momentum, and it has two linearly independent states of polarization. Fine. What do we know about photons? That is the first thing which we need to keep in mind. Then the solution to this problem is very easy. Okay, so what are photons? So in a summary, photons are massless quantum particles. Quantum particles of what? Quantum particles of light. Right. Number one, its rest mass is 0. Number two, it has energy and momentum, which we will be verifying soon. Okay, its spin angular momentum is s equal to 1. Okay, so it's a spin 1 quantum number, a spin 1 quantum particle, and it has two physical polarization states, which we will be also observing. Two physical polarization states. Okay, now let us verify each of these options. Okay, so option A. So it is given that in option A that its rest mass is 0, correct. Okay, m0 is 0 for a photon, but its energy content is not 0. Okay, so the energy of a photon is given by h nu, where we know, right, h is the Planck's constant, right, and nu is the frequency. Fine, therefore its energy content is not 0. Therefore option A is correct. Fine, now let us check option B. So option B is saying that it carries non-zero momentum, but it is so. See, the photon momentum is P is equals to E by C, right, which is h nu by C, which is basically h by lambda, the wavelength, right? C is its velocity, the speed, the velocity of light, right? Therefore it doesn't have a non-zero moment. It has non-zero linear momentum. Sorry, I was about to say it doesn't have zero linear momentum. So this is a non-zero linear momentum. Fine, so let us quickly mark option B as well. Next, let's see, it carries 0 spin angular momentum. No, its spin angular momentum is 1. Okay, the spin angular momentum of photon is s equal to 1. Okay, it has only two helicity, it has only two spin projection states, +1 and -1. Okay, and so it's not 0, though it has a rest frame. Though it doesn't have a rest frame, still its spin angular momentum is not 0. Okay, you need to keep that in mind. So C is not true, right? So C is not true. Do I have a highlighter? Yeah, so C is not true. Let's see number D. So it has only two linearly independent states of polarization. Yeah, that's correct. Why is that correct? Because number D is true. Why is it so? Because see, photon is a massless spin 1 particle, right, as I said previously. Right? It has only two physical transverse polarization, okay, which are the left circular and the right circular, in simple words, these are horizontal and vertical. Fine, and these are linearly independent. Okay, these directions are linearly independent. Okay, rather these states are linearly independent. I shouldn't call it to be direction just because I use the term horizontal vertical. The significance comes from the state of it. in terms of the polarization state of it. That is, which is the direction of the wave which is sort of filtered out due to this polarization. You can think of it in that sort of a way. Okay, so option D is also correct. Fine.